Hello and welcome to this new problem on rank correlation. This time what we'll do is we'll take a problem where there will be repetition of responses. Now when there is a repetition of responses, how do we award them ranks? We'll see this problem when we come across it. For first, let us put in some values. Let us say we have x and y and their respective values are. These are the values. Just let me check how many paired comparisons am I making. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So I am making 10 paired comparisons for the problem. Okay, let us wipe it off. Now let us go ahead and award them ranks. So we get Rx and Ry, then modulus of difference. Difference is actually modulus itself. In any case, let us write it down as Rx minus Ry modulus. And then this one would become a d square. For now, let us award them ranks. First, we go ahead with x. What is the highest value? 18. Then there is another 18. So, what rank should we give? If we give first rank to the first 18 and then second to this, that will be unfair on part of us, because same 18 is getting a first rank, same 18 is getting a second rank. So that is an unfair call. So how do we do that? What I'll do is I'll write down the ranks for which they are battling it out. First and second rank. They both are tied for first and second rank, and I'll award them average of those. So there are two elements that are fighting for same spot. I'll take average of that, and that average comes as 1.5. So I'll not award them first and second, rather I'll award them 1.5 and 1.5. Okay, average is awarded to both the tied spots. Now another issue that you need to take care is you need to keep an eye on how many such issues you come across. This was first issue, and number of ranks that I had tied was 2. 2 spots were tied, so I'll put a 2 over here. Now let me go ahead. First and second spot are gone. Next coming spot is 3. Where is 3? If we scan it, we get a 16. There is another 16. So there is again a problem for next spot. In any case, first and second rank are gone. So now the battle is for 3 and 4. 3, one will get 3, another one will get 4. So instead of awarding them 3 or 4, what I do is I award them so now the battle is for 3 and 4. One of them will get 3, another one 4, but I'll not do so. Instead, what I'll do is I'll award them average of those ranks, 3 and 4. So they both get 3.5 rank. So I'm done with 1, 2, 3 and 4 ranks are gone. The next coming rank is rank 5. After 16, if I scan, I get a 14. So this will get rank, this 14 will get a rank 5. 5 is gone. Then after 14, if I scan, I see there are a couple of 12s. So up to rank 5 is done. This will get 6, this will get 7, but that will be injustice. So instead of giving 6 and 7, what I'll do is I'll award them average of 6 and 7, which is 6.5. 6.5. So 5 was gone, 6 and 7 are also gone. The ranks that are coming now are 8, 9 and 10. So first one would be 8. This is highest. Let me award it an 8. This gets 9th and this gets 10th. So this was about ranks for X. Now let us move on with ranks for y. Who is the largest value? 17 is the largest value. But then we see that there are a couple of 17s. Okay. So for this I entered a 2. We missed this one. For this I should enter a 2. And for this one also I should enter a 2. So this is what has happened in ranks for x. There were 3 ties and each time 2 spots were being contested for. In any case, we are done with ranks for x. Now let us move on to ranks for y. What happens with ranks for y? 17 and 17. So there is a clash for first and second spot. So I'll award them 1.5. And how many ranks were tied? 2 ranks. So I'll put a 2 over there. And I'll put average ranks for them. 1.5 and 1.5. So first and second rank is gone. Let me have a look at third rank. 14 looks like being an eligible candidate, so it gets third rank. After 14 I have a couple of 13s. So 1, 2 and 3 ranks are gone. 4 and 5 are contesting for, these 13s are contesting for 4 and 5. So what I do, 4 and 5 are being fought for. I'll award them both as 4.5. So I get a 4.5 and another 4.5. So what has happened? 1, 2, 3, 4 and 5 ranks are gone. The next rank on cards is 6. It looks like only one person is contesting for it. 6. 7 looks to be going well. Then 8th, 9th and 10th rank are remaining, and we see there are 3 spots. There are 3 contestants. There are 3 values that are fighting it for rank 8, 9 and 10. 8, 9 and 10. So I'll award them the average of these 8, 9 and 10s. It becomes just 9. So I'll award them ranks 9, 9 and 9. Is that fine? So whenever I came across a battle for same spot, I awarded them average rank instead and put a mark over here. So yes, there were 3 issues over here, 1, 2 and 3. They all have been taken into consideration. Then there were 3 issues over here, 1, 2 and 3. This one has been taken into consideration. This one I have missed out. Let me put a 2 over here, and then for this I'll put a 3 over here. So this box is giving me an idea of how many times something went wrong due to a clash for same spot. Anyhow, this will come into picture just in a moment. For now, let us find out differences in ranks, and those will be 9 minus 3.5, giving me a 5.5. 7 minus 6.5 would give me a 0.5, 0. This will become 0.5. This will become 3.5. Next, let us go ahead and square these differences. So they become 5.5 multiplied by 5.5. Square of 5.5 is 5.5 multiplied by 5.5. So we get, these are the squared values. Now what do we need? We need a summation of all these squared values. If we add them all, we will get this. So now, what was the formula for rank correlation? It was 1 minus 6 sigma d square upon n cube minus n. Where n is number of paired comparisons. In our case, it were 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 pairs were being compared. But now there is a little bit of issue over here. If you recall the problem, we had a situation where we had certain ranks that were being tied. So we need to factor in that problem also, that certain ranks were tied at places. So for that, what I'll do is I'll find out correction factor. What is that correction factor? What is this C? This is correction factor. What is this correction factor? It is m cube minus m upon 12. So each time you had a problem, you have to apply correction factor. I had a problem how many times? 1, 2, 3, 4, 5, 6. My question had 6 issues. So I'll have to apply this correction factor 6 times. 1, 2, 3, 4, 5. 5 times I had same issue of 2 ranks. So 5 times I'll apply a correction factor for 2, and once I'll apply a correction factor for 3. Okay. Now what is this M? M is number of tied ranks. Number of tied ranks. Okay. So first correction factor. We very well know that I'll have to apply correction factor 1, 2, 3, 4, 5 and 6 times. So first time when I apply it, it becomes, how many ranks were tied? 2 ranks were tied. So it becomes 2 ranks were tied. 2 cube minus 2 upon 12 giving me 8 minus 2 upon 12 giving me 6 upon 12 or 0.5. Similarly, when I apply correction factor second time, again it is for 2 ranks. So it again becomes 2 cube minus 2 upon 12, 8 minus 2 upon 12 giving me 6 upon 12 giving me 0.5. Third time correction factor, this was second correction factor, again for 2, again for 2, again for 2. So 5 times, 5 correction factors are same for 2 tied ranks. So they'll all come as 0.5 only. So we can just write it down as 0.5, 0.5 each time. Fifth correction factor is 0.5. We had 1, 2, 3, 4 and 5 correction factors of size 2, and then last one is of size 3, sixth correction factor, 1, 2, 3, 4, 5, 6. So CF6, that is for 3 cube minus 3 upon 12, or making it 27 minus 3 upon 12, or making it 24 upon 12, or making it 2. So now that we have all correction factors, how many of those? We have 1, 2, 3, 4, 5 and 6. And what are their respective values? It is 0.5, 0.5. So let me add them. So total correction factor becomes 0.5 plus 0.5 plus 0.5 plus 0.5 plus 0.5 plus 2. We had 1, 2, 3, 4, 5, 5.5s and then a 2. So in all it becomes 1, 2, 4.5. So this is my correction factor. Now, as we know, the formula for rank correlation is this. But instead of using this formula, I'll make a subtle change, small change. I'll not call it squares of difference, rather I'll call it corrected squares of difference. And what are those? This was sigma d square. I'll just go ahead and add CF to it. How much is CF? It is 4.5. We can see here it is 4.5. So I'll add this correction factor to it, 4.5. And this becomes 106. So this 106 is now my corrected d square. Remember, this is my corrected d square. I'm not using this d square, rather I'm using corrected d square, this one. Okay. This is the only difference between the rank correlation that we do without any tied ranks, or in this case. What have we done? We have found out corrections for each of the issue that we faced. These were the issues that we faced, and we have put a correction for these. And now I have a DC square. Remaining everything is same. R is equal to 1 minus 6 multiplied by 106 DC square upon n cube minus n. N cube would become 10 cube minus 10, making it 1 minus 636 upon 1000 minus 10, making it 1 minus 636 upon 990, further making it 1 minus 0.6424, a total of 0.3575. So this is my rank correlation, 0.3575. Final answer is this. Thanks for watching. Bye bye.